First up, we have the module pattern, a fundamental concept in JavaScript for organizing and structuring your code. It's designed to help you group related code into a single unit, effectively protect private data from external access, and expose only the necessary public interfaces. This approach prevents naming collisions and keeps your global scope clean, which is crucial in larger applications. You should use the module pattern whenever you need strong encapsulation, such as when creating utility libraries, managing application wide configurations, or building shared modules that need to maintain their internal state securely. It's an excellent way to prevent polluting the global scope, ensuring your code remains organized and less prone to conflicts, especially in complex projects with many contributors. Next, let's explore the singleton pattern. This pattern ensures that a class has only one instance and provides a global point of access to that instance. It's incredibly useful for scenarios where you need a single, centralized control point for a specific resource or service, such as managing application wide settings, handling database connections, or coordinating logging services. Employ the singleton pattern when your application absolutely requires a single point of truth for a particular resource or configuration. However, it's crucial to use it judiciously and avoid overusing it, as excessive reliance on singletons can lead to tight coupling between different parts of your application, making it harder to test and maintain. Always consider if a simpler approach might suffice before implementing a singleton. The observer pattern is at the very heart of event-driven design, establishing a one-to-many dependency between objects. In this pattern, a central subject object maintains a list of its dependents, known as observers, and notifies them automatically of any state changes, usually by calling one of their methods. This allows for a highly decoupled system where components can react to events without direct knowledge of each other. This pattern is incredibly versatile and finds extensive use in various applications. It's great for building interactive chat applications where multiple users need to receive real time updates, developing robust event systems within your application, or even powering the reactivity in modern UI frameworks like React and Vue.js, where changes in data automatically trigger updates in the user interface. It promotes loose coupling and enhances flexibility. Moving on to the factory pattern, which is ideal when you need to create flexible objects at runtime without specifying the exact class or constructor in your code. This pattern provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. It effectively abstracts the object creation logic, making your code more modular and easier to extend. You should leverage the factory pattern for scenarios requiring reusable object creation, such as dynamically generating different UI elements based on user input or configuration, or creating various types of parsers depending on the format of incoming data. It centralizes object creation, making it easier to manage and modify the instantiation process without affecting the client code that uses the factory. The prototype pattern allows you to create new objects by copying an existing object, known as the prototype, rather than creating new instances from scratch. This method is often more efficient and memory friendly, especially when the cost of creating a new object is high or when you need to create many similar objects. It's a powerful alternative to traditional class-based inheritance. This pattern is perfectly suited for performance-sensitive applications where object instantiation is a bottleneck, or in systems that heavily rely on inheritance-based structures. By cloning existing objects, you can avoid the overhead of constructor calls and complex initialization logic, leading to faster object creation and reduced memory footprint. It's particularly useful when dealing with objects that share many common properties and behaviors. Next, we have the strategy pattern, which enables you to define a family of algorithms, encapsulate each one, and make them interchangeable. This pattern lets the algorithm vary independently from clients that use it, effectively allowing you to swap behaviors at runtime without resorting to messy and hard to maintain if else or switch case blocks. It promotes cleaner, more flexible code. Implement the strategy pattern when your application's logic needs to change dynamically based on various factors, such as user input, different filtering criteria, or even in AI systems where you need to switch between various strategic behaviors. It provides a clean and extensible way to manage multiple algorithms, making your code more adaptable to new requirements and easier to test each strategy independently. Finally, let's explore the decorator pattern. This pattern allows you to dynamically attach new behaviors or responsibilities to an object without altering its original structure. It provides a flexible alternative to subclassing for extending functionality, as it wraps the original object with additional features, enhancing it without changing its core implementation. This keeps your base classes lean and focused. You should use decorators to add cross-cutting concerns like logging, caching mechanisms, or authentication checks to functions or objects without modifying their core logic. This pattern is incredibly powerful for extending functionality in a non-invasive way, promoting the open/closed principle where software entities are open for extension, but closed for modification. It keeps your code base modular and easier to maintain. In summary, mastering these design patterns will make your JavaScript code significantly more modular, scalable, and future proof. From the encapsulation power of modules to the dynamic enhancements provided by decorators, you now have a solid understanding of when and how to effectively apply each pattern. These tools are essential for building robust and maintainable applications. If you found this deep dive into JavaScript design patterns valuable and want to continue enhancing your development skills, make sure to subscribe for more real world JavaScript architecture and design tips. Stay tuned for advanced techniques and best practices to elevate your coding game.